Welcome back to the discussion and thank you for always joining us. We are presenting a question that was done in KCSE 1998 paper 2 number 16, three-dimensional geometry. And the question we have reads, the triangular prism shown below has the sides AB being equal to DC being equal to EF, and that is 12 centimeters. The ends are equilateral triangles of sides 10. That means FC is 10 centimeters. Then of course FB is also 10. AB is 12 centimeters from the question, and EF is 12 centimeters. DC is also 12 centimeters. We have been told to find the length of BN. Roman 2 of part A, the length EN. So what we are going to do, we are going to start by dropping the line from B to move to N, such that we are going to have a right angle triangle at the point N. Remember, N is now the midpoint of FC, where we have 5 centimeters on each side. That said, we are now going to have a right angle triangle that is going to be drawn this way. We have a point B up here. We have a point N. We also have point C at this particular point. This is 10 centimeters. This is NC is 5 centimeters. So they want us to calculate BN. BN is the height, and therefore using Pythagoras theorem, BN squared would be equivalent to the hypotenuse squared, which is 10 squared minus 5 squared. 10 squared is 100 minus 5 squared is 25, giving us 75. Meaning for us to get BN, we are going to take the square root of 75, and this one is going to give us approximately 8.66 centimeters, correct to 2 decimal places. Once we have gotten part A, Roman 1 of the question, we can now get Roman 2, where we are supposed to calculate the distance EN. What we are going to do again, we connect E to N straight, such that we are going to have a triangle. We have a triangle ENF, where we have 90 degrees at point F. From there now we can extract a triangle that looks like this. This is 90 degrees at a point F. This is N, and this is a point E. We are required to calculate the length EN, and the EN is the hypotenuse. We know EF is 12 centimeters, and already FN is 5 centimeters. That means for us to get EN, we use Pythagoras theorem, where EN squared, which is the hypotenuse, must be equal to EF squared, which is 12 squared, plus Fn, which is 5 squared, giving us 144 plus 25, which gives us 169. Meaning to get En, we are going to get the square root of 169, which will give us 13 centimeters. That again has given us the answer to Roman 2. Now we can go to part B of the question. Part B of the question says, find the angle between the lines EB and the plane CDEF. What we are going to do again here, we are going to connect EB first. Remember, EB is from this point all the way to the other corner. After doing that, we are going to drop a perpendicular from a point B to N, because when we want to look at the angle between a line and the plane, we look at the projection of the plane on the, we look at the projection of the line on the plane. That means the projection of EB on the plane EFCD will be the line EN. That means we are going to have a triangle that looks like this. So from there we can extract this triangle this way and use it to answer this part B of the question. Remember, this is N, this is B, and this is E at this point. From there we need the angle theta. Remember, BN has been calculated to be 8.66. EN is 13 centimeters. Now we can use SOHCAHTOA, and therefore since we have the opposite and the adjacent, we use tan theta will be given by opposite, which is 8.66. We divide by the adjacent, which is 13, meaning the value of theta will be equal to tan inverse of 8.66. We divide by 13, and this one is going to give an answer equivalent to 33.67 degrees as the answer to this particular question. Thank you for watching and welcome to our discussion. And in case you are watching this channel for the first time, please take a second or two. You click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.